Hi, Steve here from Green Marine Lithium. Today we're going to talk about imported lithium and the issues associated with the design that seems to be making up majority of the products that we see in Australia. So these two batteries here are imported ones that we've been looking at. They're 12 volt, 200 amp hour batteries, and what you can see here is the way that batteries are designed is they actually group cells together in parallel and then groups together in series. So as you can see here, this is a 12 volt battery. Now, a 12 volt battery should have 4S, which is 4 in series, 4 cells. That's why the BMS, all BMSs for 12 volt batteries have 4 cells. That's a negative. Now, the issue is, with cells, when you connect to a group of cells, it only measures the average voltage of the 3 cells. It doesn't control current flow from one cell into another cell. Now, this is a live PO4 cell. There's no intelligence in it. It's just a cell. It doesn't push power out or pull power in. You've got to draw power out of it and push power in to charge it. It won't push power out of one cell into another. Now, there's various articles on the internet that suggest that when you connect cells in parallel, they actually balance each other out. That's false. We did an experiment where we had one cell at 20%, one about 50, and one about 80. We connected the cells together in parallel, and in about 8 hours, the average voltage of each cell came up on the multimeter. Now, when we disconnected those cells, the top of the cell, bit of aluminium up here, still registered the average voltage. But after about 8 hours, it dropped back to its original voltage. So it suggests, well, it proves, I should say, that these cells don't balance each other when they're connected in parallel. Please, if you're going to send us a message about something you've Googled, do the experiment and you'll see for yourself. Now, the problem with this is, so the BMS here, it says, righto, these groups of cells, they want to keep all the same voltage, and in theory, what the process is to keep them all the same level of charge, state of charge. Now, this BMS wire here, which I'll show you, is a 12 volt BMS, 4 wires, hence the reason it should have 4 cells. It just says, oh, okay, this cell, it doesn't know there's 3 cells there. It says this cell is 3.6, that's fine. This group here might be 3.5. So this BMS wire will go, okay, we need to put more charge into this cell here, or this group, to balance up the cells. Now, same again, this BMS wire doesn't know there's 3 cells there, and depending on where the wire is connected, it is not going to be able to detect lower voltage in individual cells. It's only going to detect the average cells. Now, this is the big issue. If you're having a scenario like this, and the average is 3.6 volts, what it can potentially do, if it says, oh, okay, we need to put some more power into more current into this cell, it will overcharge one cell. One will probably be close to being right, and one could be undercharged. Same when it discharges. Now, when you overcharge a cell, that's when you have a thing called thermal runaway. Now, thermal runaway is like getting a piece of steel, heating it up with an oxy torch. It gets to 2,000 degrees and it's red hot. It doesn't explode or catch on fire, but anything touching it will catch on fire. Now, inside this particular overseas-made battery, you've got foam that'll catch on fire. These wires will catch on fire. Here's the BMS. I don't know what the circuitry is rated at. The heat shrink over the wires, that's rated about 125. You can get up to about 200 degree heat shrink. Some electrical tape here, that'll torch pretty quickly. Now, there is, in the imported batteries, there is normally temperature sensors. Now, this particular one has 2. Here they are. I don't know if you can see. They're just going down the side of the battery. And we'll do a video a bit further on showing how these really don't detect anything. They're very sensitive, the temperatures, so they'll only take temperature in a very small radius from where they are. So there's absolutely no way in the world, if your temperature sensor is located over here, is it going to detect this cell's being overcharged. Now, what the BMS is designed to do is if voltage goes over, it cuts off. If it gets too hot, it cuts off. However, this design actually has cells in the battery that aren't managed by the BMS. Certainly the temperature is not managed in this scenario, and the voltage of individual cells is not managed in this design. When we make batteries, and we always have, we make 12 volt, 4S, 4 cells, 24 volt, 8S, 8 cells, 36 volt, 12 cells, 12S, 12 cells. So it's very difficult to know when you buy an imported battery how it's designed. And we bring in batteries at the time to check out how things are made and getting an understanding of what things are going wrong, because we could never understand why people were having issues with life PA4 when they're charging it up. Now we've worked out why we're having issues. Now the boating and electrical installation standards say you can't have this. This is against the standard, and for very good reason, because there is high risk of thermal runaway. Now, life PA4 batteries, they're safe. This is a lithium-ion batteries. They're actually safe also. They are unstable and do generate a lot of heat when you charge and discharge, but wired up correctly, they're safe. Now, what I couldn't understand either is why make them this way. It's a bigger space, it's a bit heavier, it's more welding to go on. Never made any sense to me, but recently we're starting to develop our own automated production line. Now, you can buy a production line from China straight off the shelf, probably choose about 5 or 6 of them, and they all make it this way. All the bits of machinery in the production line you can buy are designed to make it this way. Now, in production, for those of you who work in production or have got some experience in production, you're always trying to lean the production process out. You're always trying to make it more efficient, because that way you can drive the cost out of the product. Now, this design has evolved because there's a demand to have cheap lithium batteries. Now, we've all probably seen these before. These are the cheapest of cheaps. Sorry to say that you can buy an expensive one that's still made like this. Now, this particular design has 34 cells. So not 3, 34 cells with 1 BMS wire. This is also lithium ion, so if you overcharge it, they'll go off like little rockets or firecrackers. This will make up the majority of your cheap batteries. If you're buying a cheap battery, highly likely you're going to have this. Now, these production lines work really, really fast. These cells, they make billions and billions of them because they use them in power tools, cordless phone, e-bikes, you name it. All the cordless battery-powered things will generally have these, so they're very cheap to buy. Also, they're the production line can make them fairly cheap because they're very light. So when they made this particular battery, there would have been a machine that just pops out all these cells into these like egg case type things, and then a welder would go around welding them all together. Then it'd have to go to a human who solders the wire on, and as you can see, it's a pretty ordinary job. There's already corrosion, everything starting on this one. But this is the cheapest way to make a lithium battery. Now, when we make a lithium battery, I'll just slide that out of the way. So a 50 amp hour battery, whether at 12, 24, 36, we use a 50 amp hour cell. This is an 80, we use an 80 amp hour cell, 100 and a 200. Now, for a robot and a production line to move this cell around, putting it together, sort it, connect the wiring and everything else, it's a small machine. It doesn't need to be a big heavy duty machine. Now, if you want to try to move this cell around, this is a 200 amp hour cell, all of a sudden your machine that you're using is a lot bigger, a lot more expensive. It moves it slower. So this type of production line can produce about 600 to 700 batteries in an 8-hour shift. If the factory were to run this, then they'd have to stop and reconfigure the production line to take this, but they would have to use the machine that could handle the weight of this. So there's a delay. There might be a shift delay resetting the production line. Then if they want to use 100 amp hour batteries, they're going to have to do that again. So what they've decided, or what they've worked out, is use a small lightweight cell. The cost of your machinery is a lot less. You can move things faster. You can drive the cost out of the batteries. Sadly, it comes at the cost of safety. All BMSs are made. This is a 12-volt BMS with 4 cells, with 4 wires for a reason. It's supposed to have 4 cells, not 12 cells. 24-volt, 8 cells. Same reason. 8 wires, 8 cells. Now, how can you find out whether your battery's made correctly or cheaply? A lot of the companies in Australia, I haven't seen any of them, don't list how many cells are on their batteries. So my advice would be to contact your battery importer, supplier, installer, and ask them how many cells. Get it in writing. Because if it's 12 cells, you've got a battery, especially in your boat, one that doesn't meet the installation electrical standards for marine. 2, you've got a high chance of thermal runaway when you're charging. It's probably responsible for a lot of the lithium fires that we see in caravans, even certainly in e-scooters. E-scooters are probably a bit worse because it's got lithium-ion batteries as well as this type of setup. This actually here is a 24-volt, I think it's about 160 amp-hour battery. You would have to have 8 of these in equivalent, and as you can see, 8 of those is a lot bigger than that. So you can't fit 8 of those in an e-scooter, but you can fit something like that in an e-scooter. There's nothing to say they can't be used. However, each cell needs to be managed. It can't be 34 cells in a group managed with one soldered on BMS wire. It's going to be drama. Plus, secondly, if you have these sort of batteries, it's not a very strong construct. If you have to put it on its side, they're going to flop out and pull out. If they're actually designed to be installed in something upright, is probably the strongest. If you put it on its side, it's probably the weakest. So you just want to steer away from that completely. Cylindrical cells, if you ask your lithium importer. So it's very hard unless you open up the battery to sort of see what's inside. So I recommend, if you've got lithium batteries in your boat, contact your manufacturer or your importer. Ask them where it's made. Ask them how many cells they've got in it. Your installer needs to make sure that they only install the right batteries in your marine boat application. If they don't, potentially they've voided your warranty, they've voided your insurance, put you at risk. I mean, lots of people park their boats inside garages and things like that. So hopefully we found this helpful. We'll do some more videos. We'll do some extra videos coming up about why you don't connect 3 12 volts in series, especially with these type of batteries. And hopefully it gives you the information you need to make the right choices.